Last time that we had center of mass and we had done what? What was the last question we did? Do you remember? Please look in your copy and tell me. Circle. Yes, yes, yes. So last time we did, I gave you a question where I think the question was like this: that we had a circle, and from the circle, a disc was cut. The other last time, the last question. From a disc of radius 2r, a disc of radius r is cut. Find the center of mass of the resulting object. किया किसी ने? Anybody has done this? Please try this. Well, before you try, let me. Something very nice. Let me show you something else first. So in physics, we have something called the concept of negative mass. So this is a mathematical tool. It has got nothing to do with reality. Because as far as we know, there is no such thing as negative mass. So this is just a mathematical tool. Right? But mathematical tool to do what? Mathematical tool for what? So this is a mathematical tool to handle cavities. Okay. So whenever you see that somewhere mass is missing or mass has been cut out, you are going to invoke this concept of negative mass. So the way we do this is that we imagine or we reimagine this disk. And the way we reimagine this disk is that this disk, which has a hole in it, is actually made up of two solid disks. Yeah, so we have one disk of mass density plus sigma. Okay, I'm using sigma because we are dealing with we are dealing with flat surface. So we have one solid disk with density plus sigma, and on this we add another disk of density minus sigma. Right now, what do I mean by add? You have to be very clear about this. Okay? So what this means is that I am going to take the blue disk having negative mass density. Remember, such a thing does not really exist. And I am going to place this blue disk having the negative mass density not on top of the black disk. No, I am going to place it inside the black disk. Now this itself is physically impossible. आप एक सॉलिड डिस्क को दूसरे सॉलिड डिस्क के अंदर कैसे डाल दे रहे हैं, right? But again, like I said, this is just a mathematical tool, and it has got nothing. Well, there is nothing real about negative mass. So just bear with me, and I hope you will understand the purpose of this exercise. So I take this black solid disk without any cavity, and I take this blue solid disk. But the blue solid disk is made up of material having negative mass density. And then I do the impossible. I place the blue disk inside the solid disk. That means that when combined, the black disk with the positive mass density is actually coexisting, is actually coexisting with the blue disk of negative mass density. Now, wherever you have, so let me put another equal sign. So, wherever you have positive mass density coexisting with negative mass density, wherever you have positive mass density coexisting with negative mass density, it means that the net mass density in that region means that the net mass density in that region will be zero, right? And what is meant by mass density is zero? मास डेंसिटी जीरो का मतलब क्या हुआ कि वहां पे मास है ही नहीं. That means that we are dealing with cavity. So this is a very neat little trick. So whenever you are dealing with cavities, imagine that there is no cavity. There is a solid object. There are two solid objects. One with positive mass density. Now it depends whether that mass density is surface or linear or volume, depends on the situation. In this case, it is surface mass density. And this solid object with positive mass density is combined with another object, another solid object of negative mass density. And the object with negative mass density exists only in the region of the cavity. Therefore, uh, wherever there is the simultaneous existence of positive and negative mass densities, you get zero mass density, which is nothing but a cavity. So this is cavity. Okay. So let's apply this here. So I have a black disk of positive mass density at 0, comma 0. And I have a blue disk of negative mass density at r, comma 0. So the x coordinate of center of mass will be m1x1. Okay? M1 is equal to sigma into 4 pi r square. That is surface mass density into the area of the black circle into the x coordinate of the center of mass of the black circle plus mass density of the blue sphere, which will take as minus sigma, blue disk, sorry, which will take as minus sigma, into the area of the blue disk into the x coordinate of the blue disk divided by m1 plus m2. So this becomes minus sigma pi r square into r divided by 3 sigma pi r square. So sigma pi r square cancels out. We get minus r by 3. So the center of mass of the combined object, जिसमें कि ये डिस्क को हटा लिया, okay? So the maths studying you that the center of mass will be r by 3 distance along the negative x-axis. Okay, I hope this is clear. If it is, you should be able to do the next question. Repeat for a sphere of radius 2r with a cavity, with a spherical cavity of radius r. So the diagram is same. हाँ, negative mass density, Radhika. Wait a minute, I will just explaining that. Negative mass density. हो गया? ये वाला आंसर करो. Tell me the answer to this. Ah, very good. Yes. Very good, Vedant. Anybody else? Very good, Sonal. बहुत बढ़िया. Anybody else? Only Vedant and Sonal could solve. बहुत बढ़िया राधिका. Good. Well done, Abhijit. बिल्कुल सही. और कोई नहीं? अरे तो सत्य उसको सॉल्व करके बता दो ना. सही है बिल्कुल. नहीं शुगर. बोला R/3 तो इसके लिए आया ना, डिस्क और इसके लिए. So diagram remains the same. So basically now what is going to happen is that I have a solid sphere of positive mass density, and inside this solid sphere I place another solid sphere of negative mass density. Right? Impossible to do physically. मैं आपको ये नहीं बोल सकता कि आप एक सॉलिड क्रिकेट बॉल को एक सॉलिड bowling ball के अंदर डाल दीजिए. राइट. I can't do, you can't do that. But यहाँ पे mathematically we are doing that. So the coordinates of the center of mass of the solid sphere of radius 2r 0, 0, and the coordinates of the center of mass of the solid blue ball, blue sphere r, 0. So the x coordinate of center of mass is equal to mass of the first sphere into x coordinate of the sub 0, z coordinate 0, z coordinate of center of mass 0, y coordinate of center of mass 0, plus the mass of the other ball into the x coordinate of center of mass of the other ball divided by mass of the first ball plus mass of the second ball. So here we have plus rho into 4 by 3 pi 8r cube, because 2r ka cube is 8r cube, minus rho. Remember the blue ball has negative mass density. Minus rho 4 by 3 pi r cube. Similarly here rho 4 by 3 8 pi r cube minus rho 4 by 3 pi r cube. So this is very simple now. Minus rho 4 by 3 pi r cube into r divided by 7 into 4 by 3 pi r cube into rho. So this object and this object will cancel out. The answer will be simply minus r. Okay, right? मैं थोड़ा आगे बढ़ रहा हूँ. As I move ahead now, the maths now you have to be careful about. So I will go very, very slow. Okay, I will take it very, very slow. And at any step you don't understand, please, all you have to do is type. Okay. I'm going to the next slide. So the next thing we want to do is we want to find the center of mass of continuous objects. Right, but now you may say that wait a minute, we have been finding the center of mass of continuous objects. After all, the disk and the square वाला जो था, और the sphere and the cube वाला जो प्रॉब्लम था, या फिर जो डिस्क में कैविटी कट कर दिया ये प्रॉब्लम जो था, ये सब तो कंटिन्यूअस मास थे. तो हमने तो इनका निकाला सेंटर ऑफ मास, and you would be absolutely right, except for the fact that we were finding the center of mass of symmetrical and uniform continuous objects. Okay. Now we know that circular ring, for example. So we know that if an object is symmetrical and uniform, then the center of mass will lie at the geometrical center of that object, right? So there is not a lot of calculation involved there. So if I have a collection of such objects, such symmetrical objects, and somebody says, "Can I please find the center of mass of this collection of objects?" then there is no problem. जो अभी तक हम करते आए हैं वही करेंगे, and that is that we take the center of mass of each and individual symmetrical and uniform object, right? And then we again find the center of mass. So basically we are doing it twice. हम हमारे पास एक कलेक्शन ऑफ ऑब्जेक्ट्स दिया हुआ है, फॉर एग्जांपल डिस्क एंड स्क्वायर. हमने क्या किया, डिस्क को रिप्लेस किया उसके सेंटर ऑफ मास से, स्क्वायर को रिप्लेस किया उसके सेंटर ऑफ मास से. तो अब हमारे पास दो पार्टिकल्स आ गए, दो पॉइंट पार्टिकल्स आ गए, और हमने इन दो पॉइंट पार्टिकल्स का सेंटर ऑफ मास निकाल दिया. तो हमें पूरे सिस्टम का सेंटर ऑफ मास मिल गया. बट द क्वेश्चन अराइजेस that what would happen if the object is not symmetrical or it is not uniform. Okay. Then can we find the center of mass? The answer is that for a limited set of cases, we can. Okay. However, of course, that limited set of cases is very large. I'll show you हम किसका center of mass निकाल सकते हैं, किसका नहीं निकाल सकते. So we want to now move on to finding the center of mass of objects which are not symmetrical, which are not uniform. Right? However, to start this, I will find the center of mass of an object which is symmetrical and uniform. So the reason why I want to do this is that I want to show you the mathematical technique that we are going to use. Okay. And again, like I said before in the last chapter, and I think I said in the last class also, that this is going to become the staple of physics. This is how we will be solving physics of this track. Okay. तो हीट एंड थर्मोडायनेमिक्स में इसका यूज ज़्यादा नहीं होएगा, ऑप्टिक्स में इसका यूज नहीं होएगा, वेव्स में इसका यूज नहीं होएगा. लेकिन जो टॉपिक्स हम पढ़ रहे हैं, that is mechanics, electricity and magnetism, उसके बाद से EMI एंड AC, AC में तो नहीं होएगा बट EMI में बिल्कुल पूरा फिर से यूज होएगा. So this is a very very big part of physics which you have to understand. So I am going to the mathematics behind it. Okay. So I am going to first find the center of mass of an object which is symmetrical and uniform. Right. So you already know the answer to this, but the mathematical technique is what is important. So we are finding the center of mass of a thin rod of mass m, length L. Okay, right? This is what we want to find. We know that the x coordinate of center of mass, just a moment. We know that the x coordinate of center of mass of an object is given by summation mi xi divided by summation mi. Right? And we know that the y coordinate of center of mass is given by summation mi yi divided by summation mi. राइट. सो समेशन एम आई एक्स आई, इसमें किसी को कोई कंफ्यूजन नहीं होना चाहिए. समेशन एम आई एक्स आई इज सिंपली m1 x1 प्लस m2 x2 प्लस m3 x3, and summation mi in the denominator is nothing but m1 plus m2 plus m3 and so on. पहले विश्वजीत इस पे पहले ध्यान देते हैं, ठीक है ना. मैं बाद में आपको स्लाइड दिखा दूंगा. प्लीज एवरीबडी प्लीज पे अटेंशन हियर. ओके, very very important. So the formula that I have written right now is the formula to find the center of mass of discrete objects. Okay, so even if I have a circle and a square, or uh, I have sphere and a cube, uniform अगर है वो, तो you can always consider them to be discrete objects. अगर मैंने इसका बोला center of mass निकालने के लिए, तो what you will do is you will say, okay, the objects that I'm dealing with are uniform, they are symmetrical, so they can be easily replaced by point particles located at the center of mass. Right? So you have converted a set of continuous objects into a set of discrete objects. Once you have done that, you can simply apply this formula where mi would be the mass of the circle, xi would be the x coordinate of the center of mass of the circle, right? And then again mi, the next value of I, would be the mass of the square, and xi would be the center of mass, the x coordinate of center of mass of the square. Okay? So this is what you do for discrete systems. So for point objects, but for solid objects or for continuous systems, all you do is you convert this formula into an integral. So x coordinate of center of mass now becomes integral x dm divided by integral dm. The y coordinate of center of mass now becomes integral y dm divided by integral dm. Right. Now it is very important that you know what is x and y, right? Although x and y have the same meaning as before, but still I must point this out. So x and y are the xy coordinates of the chosen elements. Okay? If, very big if, elements are point particles. If the elements are not point particles, then x and y are xy coordinates of the center of mass of chosen elements. Right? So the statement that I've written in red is pretty much this. In fact, it is exactly the same as what we were doing up till now. So if I gave you a question in which there are four distinct point particles and I give you their coordinates, right, then it is a very straightforward question of application of that formula, the upper wala formula, same summation of mi xi divided by summation of mi. So if I give you four particles and their coordinates, then all you have to do is पहला पार्टिकल का मास इंटू पहला पार्टिकल का एक्स कोऑर्डिनेट प्लस दूसरा पार्टिकल का मास इंटू दूसरा पार्टिकल का एक्स कोऑर्डिनेट एंड सो ऑन divided by the sum of masses. However, if I give you a collection of if I give you a collection of continuous objects, if I give you a collection of solid objects, then what you will do first you will reduce the solid objects into point particles, and these point particles will be located at their respective center of masses. So for example, if I asked you to find the center of mass of a sphere and a cube which are kept together, then what you do first is that you find the x and y coordinates of the center of mass of the sphere and the cube, and then you apply the formula summation mi(xi), where mi or m1 will be mass of the sphere multiplied by x coordinate of the center of mass of sphere plus mass of cube into x coordinate of center of mass of cube divided by the summation of mass. Right. So the same thing I am saying here. I am saying that instead of writing summation mi(xi), you are going to write integral x dm, okay, where the x would be the x coordinate of the particle itself if your chosen element is a point particle. But in case, and we will see how this pans out, but in case if your chosen element is not a point particle, then this x represents the center of mass coordinate of the chosen element. Okay, so I hope that most of you are finding this mysterious and unintelligible, but but very soon, in around 45 minutes, you should be able to uh, very nicely grasp what I'm saying. So I want to find using this set of equations now. I want to find the center of mass of a thin rod of length L. Okay, so I'm going to change the slide. यहाँ पे जगह नहीं बची है. I will change the slide and I will do it on the next slide. Please follow me very, very carefully. Okay? Please follow me very, very, very carefully. So I have been told that this rod, thin rod, that means thin का मतलब होता है that it exists only in one dimension. So this thin rod has a length of L, has a mass of M, and we have to find the location of the center of mass. Right? We already know the answer, but I want to show you how to apply the formula. Okay. I want to show you how to apply the formula that we have. Okay, so just like any problem that we will be dealing with of continuous systems, we have to apply calculus. Okay, and the methodology or the philosophy behind this application of method of calculus is that you divide this object into elements, into some basic unit of construction, which should be infinitesimally small. So what I do now is I take a sword, talwar leke, and then I just chop this rod into little tiny pieces, slices, right? So this is how I chop the object, and out of the infinitely many small pieces, infinitely many small slices, I have to choose one. ये सब कैलकुलस का मेथड है, हमेशा ये मेथड सेम रहेगा. प्लीज नोटिस दैट अभी तक मैंने सेंटर ऑफ मास की बात ही नहीं करी, because this method will be applicable for many things, many physical properties. So first of all, first step is to arbitrarily choose an element. Uh, an element is a basic building block of the object. So basically, what I'm saying is that this rod is made up of these infinite slices placed adjacent to each other. After that, you have to introduce a new variable. Right? This is a very important step. So this new variable must be such that it is able to locate the element that you have chosen. Okay? And for location, remember, you need 2 points. कहाँ से कहाँ तक. तो कहाँ तक वाला जो प्रॉब्लम है, that is already solved, because कहाँ तक होना चाहिए, तो ये एलिमेंट तक होना चाहिए. कहाँ से मेजर करें? So we should always measure the distance from a fixed point. Okay? Otherwise, it becomes meaningless. Right? तो अगर मैं किसी शिप का पोजीशन मेजर करना चाहता हूँ, a ship which is sailing in the ocean, then it would be meaningless to measure the position of that ship uh, from uh, from another moving ship, right? Because वो केवल मूविंग शिप के रिस्पेक्ट में एक आपको करेक्ट आंसर मिलेगा, बट बाकी किसी को करेक्ट आंसर नहीं मिलेगा. बाकी किसी को अगर लोकेट करना होगा तो उसको जो पहली शिप है उसका भी वेलोसिटी और सब चाहिए होगा, दूसरी शिप है उसका भी वेलोसिटी और बाकी सारी इंफॉर्मेशन चाहिए होगी टू इंटरप्रेट द आंसर. So you need one fixed point. Yeah? So here I am going to choose this end of the rod as the point. Okay? I'm going to choose. I'm going to. I'm going to measure the distance of the element from this point. So I introduce a new variable. I say that look, this object, this element that I've chosen is at a distance of x from this end of the rod. And the moment I say this statement, the moment I decide that the variable that is going to locate the element is x, automatically I must also say, in the same breath, in the same sentence, I must also say that the width of the element is dx. Right now, this is important. You cannot say that the location of the element is at a distance of L from the end and the width of the element is dx. Right? That would be meaningless. It has to be the same d term as that of the location. Okay, and this is important because you are saying now that look, what I have done is I have taken these little tiny disks, little tiny point particles, the red object that I've drawn. I have taken these little guys and I've placed them adjacent to one another. Right? I've started with one, then I've placed the other, then I've placed another, then I've placed another, and I kept on going until now I am at that location where I'm placing the red wala element in the construction of the rod. Okay, and when I do that, I am at a distance of x from the end of the rod, and I will keep on placing these red elements adjacent to each other uh, until I get to the other end of the rod. Right? But for the moment, I have reached a distance of x. Okay, and like I told you before also, the moment you do this, अब अर्जुन की तरह आपको केवल वो रेड ऑब्जेक्ट दिखाई दे रहा है और आपको कुछ और नहीं दिखाई दे रहा है, राइट? You only see the red object. So now I can apply the formula. X coordinate of center of mass, y coordinate will be 0, so I don't need to worry about that. X coordinate of center of mass will be integral of x dm divided by integral of dm. Okay, so this will be equal to integral of the x coordinate of the chosen element if the element is a point particle, and this red guy is definitely a point particle. I've drawn the red guy थोड़ा सा elongated just for visual representation. Otherwise, this is a thin rod, and therefore the red guy is really a point particle. Yeah. So the x coordinate of the point particle, which is x in this case, multiplied by the mass of the point particle, multiplied by dm. Now remember, I told you when we discussed those densities that you can take dm is equal to lambda into dx. Okay. Lambda क्या चीज है? Mass per unit length. So if you are not convinced with this argument immediately, right? Please remember that I have used unitary method. So length L में अगर mass m है, unit length में mass m by L होएगा, और dx length में mass m by L into dx होएगा, और m by L mass per unit length को मैंने बोला है कि हम lambda से represent करेंगे, तो ये lambda dx हो जाएगा. Now this should come naturally. dm is equal to lambda dx. Yeah, sigma is equal to dm is equal to sigma dA, right? And I told you that sigma की values बहुत ही अगर sigma आ गया तो dA की values बहुत ही limited होती हैं, and dm is equal to rho dV. In this case, lambda dx divided by integral of lambda dx. Okay, so let me just rewrite this properly. I can take lambda out of the integral because it is a constant. I can take lambda out of the integral because it is a constant. And outside they just cancel out. Yeah. Now comes the very important part. I cannot carry out this integration right now because I need to have limits. Always remember that you can never ever carry out an integration. You can never ever carry out an integration unless unless you have uh, knowledge of the limits. Okay. So to find the limits, what you need to do is you need to identify the element which is or which are at the extremes. So this is the element at one end of the rod. This is the element at the other end of the rod. Right now, for this guy, for the first element, for this guy, what is the x coordinate? So the x coordinate for this guy is equal to 0, and the x coordinate for this guy is equal to L. Right? So the limits will go from 0 to L. 0 to L. So the integration of x dx is x square by 2. Limits are 0 to L. And the integration of dx is simply x. Again, the limits are 0 to L. So I get L square by 2 divided by L, which is equal to L by 2. Right? And we already knew that the center of mass x coordinate would be at the center of this rod because it is symmetrical and it is uniform. Okay? I hope the steps are clear. I will repeat the steps once again. Okay? And this only comes with practice. ऐसा नहीं है कि आप steps रट लोगे तो आपको you will be able to do the question. No, it comes with practice. So the first step is always to divide the object into elements. Okay, and I will show you how to do that as we progress. If you see a linear object, okay, if you see an object like a rod or a ring or something which exists in one dimension, then all you do is take your knife, take your sword, and just start chopping up the object, and you will end up with the element which will be a point particle. The next step is to locate this element, and to locate this element, all you do is you consider a variable from one end of the object. In this case, from one end of the object. In other cases, from some other fixed point. Once you have located the arbitrarily located the element, all you have to do now is introduce a new variable because ultimately the location of the uh, element that you have chosen is arbitrary, right? By definition, you can't choose that element which is located at L by 2 or L by 4 or 3L by 4 or 3L by 8. No, must be arbitrary. So therefore, to make it to make your choice of element arbitrary, you have to introduce you have to say that look, this element is at an unknown distance from one end in this case. So I choose the new variable to be x, and therefore the length of the element automatically becomes dx. If I had chosen this length to be L, then the length of the element would become dl. If I had chosen this length to be r, then the length of the element would automatically become dr. Okay, that is how you denote objects, denote things. Next, once you have located the element and you have introduced a new variable with the corresponding d term, all you have to do is write down the value of the x coordinate of center of mass in this case. But in general, you have to write down the value of the physical variable that you are trying to find out for the whole object in terms of this x and dx. Okay, so I have written the value of the x coordinate of center of mass in terms of x and dx. When you do that in this process of writing the physical variable, at some point of time, you may have to use unitary method. In this case, we have a shortcut, and that is that dm can be taken as simply lambda dx. Okay, but if you want to go through this L length में mass m है, unit length में mass m by L है, that's okay. So once we have said that dm is equal to lambda dx, okay, I just place everything inside that formula, right? And I end up with an integration, integral x dx divided by integral dx. But I cannot carry out this integration without finding the limits first. I must find the limits. To find the limits, all you have to do is look at the object again and find out the extreme elements. Okay. अब extreme element का मतलब क्या हुआ? Obviously, the object is going to have some physical dimensions, physical limitations. So therefore, what you do is जो भी आपने element choose किया है, आप बोलोगे अच्छा ठीक है, rod के लिए मैंने ये point particle choose किया, तो rod के एक end पे point particle होना चाहिए, दूसरे end पे point particle होना चाहिए. तो इन दोनों point particles के लिए मेरे जो variable जो मैंने choose किया है, उसकी क्या value होनी चाहिए? Remember, x is the blue arrow which originates from that yellow line and goes to the location of your element. So if you have chosen this guy, okay, if you have chosen this guy, उसके लिए x का क्या value होएगा, and if you have chosen this guy, इसके लिए x का क्या value होएगा, that will decide your limits. Once you have decided your limits, you can carry out the integration. That gives you the answer. Okay, right? I hope this is clear. Abhi, if you want to ask me anything, please do. If you want to ask me any question on this procedure. Exactly, yes. This is why the potential energy of a vertical rod is minus mgl by 2. Yes, very good. Yes, Abhijit, yes, exactly. So now, whenever I ask you the potential energy of a rod, you don't really have to do any integration. You can just say, अच्छा इसका center of mass का निकाल देते हैं. Potential energy, that will give me the answer. Okay? This is a very, very powerful tool. Yes, it is absolutely similar to the potential energy wala question, and it is absolutely similar to the questions that we are going to do in the next chapter, then in the next chapter, then in the next chapter, then in the next chapter. In fact, in all the chapters that I am going to discuss with you. Ha, Ishwajot. Yes, very good, bacha. Yes, limits we find the maximum and minimum values of x. Very good. Yes, I don't think I can put it better than that. बहुत बढ़िया actually. Very nice. Ha, Zohaib. Yes. So PE, potential energy, you can always say is mg multiplied by the location of the center of mass from the reference level. Yes. आगे बढ़े भाई. हो गया? Any other question you want to ask? बाकी लोग as usual शांति, कोई सवाल नहीं. हाँ. Okay. So now we are going to do a very important exercise. Now I'm not giving you a question, okay, but this is a part of theory, and I want you to work it out yourself. And unfortunately, I don't like saying this ever, but unfortunately, you have to remember the results, okay? Because you will not have time to derive these things at the last moment. Whenever I say you have to remember, what I would suggest, what I would recommend is that on a chart paper, you simply write down the results and stick it in front of your study table so that it will always be in front of your eyes. So I'm not going to write the question, but I am going to write what we are going to find or what you are going to find. And remember that this is standard part of the theory. Therefore, it has to be remembered. Center of mass of a half ring of radius So here we have a half ring, and we are supposed to find the center of mass of this half ring. Okay, so I want you to do this. I want you to first find the x coordinate of center of mass using, of course, ये वाला formula, integral x dm uh, divided by d. Right. So let me just, I think somebody was, please take a screenshot or just write this down. Okay. सुबह वाले में राधिका मैं लाइट बोर्ड पे क्लास नहीं ले पाऊंगा, सेकेंड या थर्ड क्लास होगी तो पॉसिबल. But I'll start. Okay, so not finding a way to start, I will help you. Whenever there is a linear, and we have discussed this, whenever there is a linear distribution in a straight line, then it will be x dx, LDL, RDR, YDY, whatever you want to use. Very good, Abhijit. Excellent, bacha. Excellent. Yes. So, नहीं अभिजीत, गलत आंसर है. पता है क्या किया है? हाँ, yes, good. Whenever there is a circular, arrangement, then you have to choose an angle. So let me just start this off for you. So let this angle be theta, and let this angle be d theta. Okay, so this is our chosen element. So now you have the chosen element. Please try to apply the formula to find the x coordinate of center of mass. हाँ, step बिल्कुल सही. इंटरनेट पे सर्च करके आंसर नहीं देना है, वर्कआउट करके आंसर देना। हाँ तो वर्कआउट करना है ना, the object of the exercise is working it out. नहीं, no. Very good Vedant, yes. नहीं, सिग्मा नहीं यूज करेंगे ना, इसमें हम लैम्डा यूज करेंगे, लैम्डा। नहीं, नहीं, sure. Chalo, I'll solve it. So I told you that once the element is chosen, then you should be like Arjun and only look at the element. Okay, nothing else you can see. You can only see the red dot. So for the red dot, what are the x coordinate and the y coordinates? Well, the simple right angle triangle. This must be r cosine theta, and this must be r sine theta. Right? So the x coordinate and y coordinate of this element is r cosine theta, comma r sine theta. So xum, which is equal to integral x dm divided by integral dm, must be equal to integral of x coordinate of the element, which is equal to r cosine theta into dm, which is equal to lambda into the length of the element. Right? And we have done this again. So this downstairs, it will simply be lambda into the length of the element. So we know that angle is equal to arc upon radius, and therefore the length of this element must be equal to r d theta, that is radius into angle. Okay? So I get x coordinate of center of mass is equal to integral of r cosine theta into lambda r d theta divided by integral of lambda r d theta. Now I cannot go anywhere before deciding the limit, so what I do is I locate the extreme elements. पहला extreme element ये रहा और दूसरा extreme element ये रहा. तो ये पहले एक्सट्रीम एलिमेंट के लिए थीटा की क्या वैल्यू है, राइट? Angle is equal to arc upon radius. Angle is equal to arc upon radius d theta is equal to arc upon arc. Arc is equal to r d theta, right? You should remember this. It's very easy to remember. So this is one extreme element for which what should be the value of theta? This is one extreme element for which what should be the value of theta? The value of theta should be 0 for this guy. And this is the other extreme element. What should be the value of theta for this guy? What should be the value of theta for this guy? So it should be 180 degrees. It should be pi. Theta is equal to pi. So the limits of integration are from 0 to pi, for which I can rewrite this as constant सारे बाहर लाके lambda r square integral of cosine theta d theta 0 to pi whole divided by lambda r integral d theta 0 to pi. Lambda r cancels out, and I get r into integral cosine theta is simply sine theta 0 to pi divided by integral d theta, which is theta 0 to pi. Right now, this is very, very weird because sine pi, that is sine 180 degrees, is 0. Okay, sine 180 degrees is 0, and sine 0 is also 0. So r sine pi minus sine 0 divided by pi is equal to 0. So the x coordinate of the center of mass is 0. Okay? So did I do all this hard work for nothing? Well, not nothing. We learned the technique. X coordinate of center of mass is coming out to be 0, which should have been obvious when we started. If an object is symmetrical about the y-axis and is uniform, if an object is symmetrical about the y-axis and is uniform, then the x coordinate of center of mass must be 0. Why is this so? It is so because of the fact that if there is an element here having some positive x coordinate, bound to be there is bound to be an element here with exactly that same negative x coordinate. Right? So m1 x1 plus m2 x2 will always be 0. And you can always find these corresponding particles on the two sides because this object is symmetric about the y-axis. Right? So if an object is symmetric about the y-axis, the x-coordinate of the center of mass of that object is 0. And if an object is symmetric about the uh, x-axis, then y-coordinate of center of mass is 0. Right? Yes, Satyam. Center of mass of an object can definitely exist outside the object. Center of mass of an object can definitely exist outside the object. Chalo. So I have done x coordinate of center of mass. Okay, I will change the slide. Well, in fact, I will not change the slide. Now I will ask you to find the y coordinate of center of mass of this object. Okay, and the y coordinate of center of mass will not be 0. It will have a value. Maths will be exactly the same. So try to do it yourself in your copy. Don't look at the screen. When you get stuck, of course, you can look at the screen and see. Please tell me the y coordinate of center of mass of the half ring of radius r. नहीं, limits will not change. No, why should the limits change? जो extreme वाले objects हैं उनके लिए, हाँ शर्वार, very good, yes. जो extreme objects हैं उनके लिए तो 0 और pi है ना. हाँ अभिजीत, लेकिन x coordinate तो 0 आया ना. I think you answered that for x coordinate, right? माइनस नहीं आएगा, समझो देखो. हाँ सब. Remember that integral of cosine, integral of sine will be minus cosine. हाँ अबिन बिल्कुल सही. एक एक टर्म मिसिंग है अबिन, देखिए. So integral of sine is minus cosine. हाँ भव्य. And cosine pi is -1. Cosine 0 is 1. हाँ अबिन बिल्कुल सही. अब सही. माइनस नहीं आएगा ईश्वरजोत. माइनस क्यों आएगा? So I'll change the slide and I'll then do this. Nice angle of answer है. देखिए. Y coordinate of center of mass is equal to integral of r sine theta into lambda r d theta divided by lambda r d theta 0 to pi 0 to pi is equal to lambda r square integral of sine theta d theta divided by lambda r integral d theta 0 to pi 0 to pi, which is equal to r into minus cosine theta 0 to pi divided by theta 0 to pi. This is equal to r multiplied by minus cosine pi minus minus cosine 0. Okay, I put in the limits divided by pi, which is equal to 2r by pi. So for this half ring, center of mass is here, where this distance is 2r by pi. Okay, this is the center of mass. Chalo. Please take a screenshot. Slide number 1. Slide number 1. Number 2, where I explained the concept of negative mass. Please take a screenshot. Keep taking screenshots. Slide number 3, where we worked out for spherical cavity inside a solid sphere. Slide number 4, how to find the center of mass of continuous objects. Okay, the thing which is written in red is very, very important, as we'll see in the next class. Slide number 5, we found the x-coordinate of center of mass of a thin rod of mass n and length l. Right? This was just to show you the mathematical technique. Slide number 6. This is, as I said, part of theory. So around 5, I think 5 things we have to find the center of mass for. पहला निकाला है, 4 अगली क्लास में निकालेंगे. So we found that the x-coordinate of center of mass is 0, and this is how to deal with circular mass distribution. And then finally, slide number 7, where we found the y-coordinate of center of mass of the half ring. HCV start करिए please. Yes, thank you so much for reminding. Please start HCV now. शुरू के 10-15 क्वेश्चन हो जाने चाहिए, और एटलीस्ट जहां पे लिखा हुआ है फाइंड द सेंटर ऑफ मास, दैट यू शुड बी एबल टू डू नाउ. ओके, चलो, so we'll meet in the next class tomorrow. Chalo guys, bye bye. Okay, again you need practice in this. So if you want, इसके आगे half disc आने वाला है, उसके आगे hemisphere आने वाला है, उसके आगे solid hemisphere आने वाला है. Right? So if you can find the center of mass of these objects as well at before the next class, तो बहुत अच्छा रहेगा. नहीं तो I will discuss in class anyway. चलो, bye bye.